don't hesitate at all. Bring some of these questions to class.
I do have a question here. You asked for the listen the force based on measured as opposed to then force based on theoretical. What's the difference?
Okay. The force of the post based on measured. That's what did you measure at the post?
Yeah, but is that the same as what? Like I have the 27 written down there. That's what the scale showed when we pulled it.
Mm-hmm.
So would that also be the same for the other one?
The post.
At the post, or is that a different? That's what I'm confused on.
So did you only do one measurement or two?
I only did one, but it goes back to if you calculated it at the pulley, you can also calculate it on the other side of the post.
Okay.
So if you measured it at the pulley, you can calculate it what it is at the post.
So
since they're not 45-degree angles, they're not going to be the same.
But we still never had it measured, right?
You didn't have to measure it to calculate it.
But
It's based off measurement.
I guess I don't really understand what the difference between that and the theoretical.
There it is.
It's essentially the same equation, except you're using different values. It just shows that there's difference.
So is your measure the one that we're doing?
I see what you're saying. Okay. One is you're starting at the back of the. They're both theoretical, but one is starting by the measured force at the back of it, and one is based on the theoretical force at the back side of it. So they're going to be very similar answers, and basically it's the same technique.
Yeah, it's the same technique, so it's just more practice.
So the first part you measure the force that you're pulling back, right? You also calculate that force you're pulling back. Those should be fairly close, ideally. So then from those two values, you solve this problem and this problem, and they're going to be very simple. Same procedure. You just get to do it twice. Anything else? Okay, we ended up the last class calculating how much water, how much electricity I waste going through the block. So it's $60 roughly. So we had energy is mass times gravity times height. Basic equation, one that you need to keep familiar with. I should mention, I guess I haven't talked about the tests, and let me say something about it right now. The tests will be very similar to the lab and homework problems you do. The problems you'll see will be fairly similar. You'll have a problem with vectors, that's like the question you asked. You could have a problem with some ropes and pulleys and calculate the force over here. You could have those kind of things. So they'll be very similar to your homework type problems. So there's a lot of equations. You get to have a full 8.5 by 11 one-side sheet. You can write all your equations on there. So what I would encourage y'all to do is, as you start accumulating these equations, kind of keep a master sheet, because it won't be a closed book test, but you have all the equations you want to write down. If you ask me an equation, I won't help you. You will have access to units. You don't have to write all your units down there. I'll either give you a set of units, and if you don't happen to have one you want, I'll tell you what it is. If you have a question of units. So don't worry about the units, conversions. But your equations, you want to start accumulating those and writing them down. The ones that you start using a lot, you'll need those. Okay. This is one of them. This is one for energy, gravitational. Mass times gravity times height. I'll give you another example. This one's starting to dry on here. Got a pallet full of bricks. And you're going to raise this thing up 10 meters. And this is a mass, half a ton, let's say, 1,000 or a ton, 1,000